This is recording 1A in our series on adding and subtracting rational expressions for Unit 6, Chapter 6 of Mathematics 2200. We'll be focusing on how we can find lowest common denominators for two or more rational expressions. Why lowest common denominators? Let's see. Well, when we're adding or subtracting fractions, the easiest common denominator to use is the lowest common denominator. So for example, if I'm adding 4/3 plus 5/2, the common denominator here would be 6. So I've got 8/6 plus 15/6. Hard to say that. 8/6 plus 15/6 gives us 23/6. On the other hand, if I had chosen to use a common denominator of 12, 4/3 is the same as 16/12. 5/2 is the same as 30/12, and then I've got 16/12 plus 30/12 is 46/12. But then I got to go to work and simplify, and it's all because I didn't use the lowest common denominator to begin with. Now, sometimes even with lowest common denominators, there's still some further simplification, but we've made it harder here again by not using the common denominator. Now, how do we find and use the lowest common denominator? Well, first of all, let's say we wanted to add these two fractions. One way to do this is to do the prime factorization of the denominator. So 12 would be the same as 2 times 2 times 3 plus 6 would be 2 times 3. Now let's follow the rules over here. The lowest common denominator must contain the greatest number of any factor that appears in the denominator of either fraction. So first of all, our lowest common denominator, LCD, we look it up. Well, we see a 2 occurs here, and it occurs a second time here. It only occurs once, but it occurs twice. Therefore, include it twice, because twice is greater than once. So it only occurs once here. Include twice. So our LCD consists of a 2 and another 2. Now the 3 only occurs once and only occurs once here. So we only need to include it once in our LCD. So 2 times 2 times 3 is 12 for our LCD. So let's look at these two expressions. We have to write their lowest common denominator. We see that in this one we only have a y. So our LCD must contain a y. However, the y occurs twice. Y squared means it occurs twice. It's like y times y. Let me fix my typo there. So it occurs twice. So that means we need to include it twice. So it must contain a y squared. Now the x occurs once there. It doesn't occur at all in the other one. So it only occurs once there. So it only gets included once in our LCD. And I like to put my variables in alphabetical order, so I'll have xy squared is my LCD. We have to write the rational expressions using the lowest common denominator. So 2x over y has to equal something over xy squared. Now we look at our LCD, it's xy squared. This denominator so far is missing an x, and it's missing another y. So we got to multiply by xy. But whatever we do to the bottom, we've got to do to the top. So in a nutshell, we've got 2x times xy, which will give us 2x times x is x squared, and y in the numerator. The second one is pretty straightforward. It already has the common denominator. so we leave it as is. Now this next one involves a bit of factoring. We factor both denominators because they are binomials in this case, and the first one's a difference of squares, so we have y minus 2, y plus 2. The second one, it has a common factor of 2. So we got 2 outside of y plus 2. So therefore, the LCD, let's see, the y minus 2 occurs once, so we include it once. And the y plus 2 occurs once here and once here, so again we only include it once. And look, we have a 2 right there, so we have to include that. Now to write the first one with the common denominator, the lowest common denominator, it's easier to use the factored form of the denominator because it's easy to see what's missing. We need the LCD of 2 outside of y minus 2, y plus 2. So the first one is, or this denominator is missing that 2. So we need to multiply the top and the bottom by 2. So we have 2 outside of y squared minus 20 over 2 times y minus 2, y plus 2. Distributing that 2 in the numerator, we've got 2y squared minus 40. The second one is missing the y minus 2 for the LCD, so we multiply the top and the bottom by y minus 2, and we wind up with y squared minus 4y plus 4 in the numerator. It's usually more useful to leave the denominator factored out. In conclusion, to find the LCD for two or more rational expressions, factor all denominators, identify the greatest number of any factor that appears in the denominator of either fraction. For example, if a factor appears once in either or both denominators, include it only once. If it appears twice in any denominator, include it twice.